Hi guys, in the last video about this variable charger we tried to find out if we can interact and control this from outside a controller and somehow replace the manual potentiometer which is put here on the device and replace it by a digital one. And we found out that this should actually work. And in today's video I want to show you the final application. And I must tell you, I'm really flattered how well this works. So it's now ramped up already to somewhere around 20 amps, and yeah, it is perfectly controllable by the digital potentiometer here. But let me start with some fun facts. No, this device has been sold to me as a 25 amp charger, and actually it's absolutely not true what they say. This is a 3 to 31 amp charger, right? What does that mean? So if you would set the potentiometer to minimum and turn on the switch, you would get 3 amps. So there is a few lights here in front of there which are changing the state, and some are showing that it's charging, or then if it's off it's not charging, or whatever that might mean. So all these lights and also this amp meter, this display what is on that charger is just fiction and is absolutely not saying anything about what's going on here in this box. So 3 amps at the minimum. If you crank up the potentiometer, even if the charging light is not on, it will still just increase, and then at 5 amps the light will jump to another place, but then it will go up, and if you set it to maximum it will be 31 amps. So now you could say, wow, that's cool, we paid for 25 amps and we got 31. Yeah, but that might be nice for a climate where you live in, but not here. As you know, in this hot and humid climate, I'm happy to get 25 amps here safely out of this, and I for surely don't want to have 31 amps. So that's why I have initially software limited the output, and now I will show you about the potentiometer adapter, and finally I have hardware limited this charger. So I really don't want to have more than the 25 amps as they say. But otherwise everything works perfectly here, and yeah, it's not even getting hot, so I think that's quite okay. It's very loud here, as you may hear now, but here on this outside wall here it does not matter to me anyways. So when I built this performance upgrade of the Powerwall, including this charger, you know, the Powerwall did not work. The reason was the controller failed, so this of course also did not work. On the next day I had the controller temporary up and running, and I had this charger on test for about 1 day. After that day the system did not work anymore. So I was looking at the potentiometer and I saw that the IC, the factory flux, was turned brownish. So I knew, okay, this is usually a sign of overheating. So I had to order another potentiometer. Luckily I ordered 2 more, and when those arrived I have put a heatsink on the potentiometer IC, installed it, tried again. It was running another day, and then at the end of the day it was broken again. When I looked at the IC, there were no discoloration anymore. I knew that it is not a heat problem. There is some fundamental issue with this idea of how to control this from the external. What I was coming up with then as explanation was that something from the charger side must interfere with the potentiometer circuitry and finally destroy it, right? If you think about, you have a manual potentiometer here built into this device. This potentiometer as a component is 100% part of the electronic circuit of this charger. But now we have added an external circuit. That circuit is partially connected to this equipment, and on the other side it's connected to the control circuit. And those two sides now are connected. And one very important thing is that the low side of the digital potentiometer must also be on common ground with the other electronics. Then of course there are currents flowing in between. There are transistors inside which are setting the wiper at a certain position. So current will flow from the control side also to the side of the charger, of course. Usually on such days when I'm testing a lot, this will be switched on and off many times, like you would switch the switch here, right? So I thought that probably during this switching there is a sort of voltage spike going from the charger into the potentiometer and finally destroying the control circuitry there. It might even be reversed polarity of what is usually going on there. And this is very important, that the digital potentiometer, that the low side is always ground and the other one, the high side, is always higher potential than on the low. Those kind of things are happening, we know this, when you turn on and off an inductor, like a relay coil or something like this. And in that case, we use a fast switching diode over the coil, which is dealing with such reversed polarity spikes, etc. So I did actually the same thing. I took a fast switching diode and put it between the VL and VH, so the low and the high contact of the potentiometer, in reversed bias. So if there would be a reversed voltage spike coming from the charger, it will not go through the potentiometer, it will go straight through the diode. And since I did this, I have never had any problems. This is working really like a charm. This is our final adapter now. You can see all the components which are required. Connectors, we have our pull up resistors, an LED, the fast switching diode, and the trim potentiometer is a 2000 ohm trim resistor. And yeah, with this trimmer actually I could set any value on the charger between 20 to 31 amps as a maximum output. So this is very nice, a nice feature. So you see, it's not just that you can buy a breakout board and that will do everything you need. So such an adapter can be very important, and here we can now just plug in the digital potentiometer with the heatsink on it, and that's okay. It is early morning now. On the lower screen, this is now dedicated only to the variable charger. And there you can see the status of the charger, which can be on or off, and then the current target which the charger is trying to maintain, and right of it is the readout of that phase, the actual power there. So we have now available power about 330 watts. That would usually be enough to regulate the charger, but at the beginning we are waiting a little bit for a sort of buffer. And when that value reaches around 500 watts, the charger will then turn on, and it will remain on until at the evening when the inverters switch on again. So the charger is waiting in the morning just to change the state one time, and then during the day, if it does not need to produce any power, it will just regulate down to its minimum but not turn off completely. Right, it is a sort of protection for the circuit there, that you know, all the switching is surely not healthy for the electronic, and it was certainly not healthy for my digital potentiometers. We're gonna wait a few more minutes and then you will see the charger turning on, and when it regulates it will try to maintain somewhere remaining excess of around 100 to 150 watts. So that is then its operational buffer which it will try to maintain, so and it will then go between its minimum and maximum up and down as it is required by the excess and loads on that phase. Yeah, as you saw, the charger has started and it's already producing 23 amps, nicely following the excess energy remaining around 100 watts, and it will do so now in its control range. So as soon as the charge is on, as I told you, it will produce around 3 amps of current, and at the moment 23 amps is the maximum, which I have limited by my potentiometer adapter, right? So I have set the potentiometer like that the output does not exceed the 23 amps here. The charger could do around 31 amps, but for some obvious reasons I am not going so high on the charger, because it is sold to me as a 25 amp charger and the climate here is harsh enough to ask the rated power of some electronic device anyway, so I'm not going to exceed it. So this will now go on like this for a while. We will see some changes by following the excess. At some point, when there is more power than this now available, the charger number 3, which is a fixed output charger on the same phase, will then engage, and there will be a sort of switch over, a handshake between these two chargers, so that there's a smooth startup of the charger number 3. Right, for that I have to first control the output of the charger 4 to its low position, and then start the charger 3, and once this one has reached full output, then the charger number 4 will start and continue to remove the rest of the excess from that phase again. You see now the charger, the variable charger is on full output for a long time already. We have extra 500 watts. So the decision for the fixed charger is made by a power cycle which is going over 6 minutes. So if the power is enough over that period, it will switch on. So we have this 500 watts now for some time. Within the next cycle, that charger should actually switch on. And now we can see a handshake. The charger 4 throttled down the target to its minimum, and while now the charger 3 is ramping up, it will still stand by until the charger 3 has its full power, and now it takes the remaining excess energy of that phase and goes back up to power as well. So we have now charger 3 20 amps and the charger 4 now at 12 amps, 13 amps, so 33 amps is removed from that phase now seen by the DC side. Yeah, and this will now go on all the day. If the phase does not support these two chargers anymore, the fixed charger will then shut down again, and the variable charger will still continue to follow the excess energy. It will then go on like that until the evening, until it's time to invert power from the battery back to our AC system, and then the charger 4 will finally shut off again and wait until next morning, until this cycle starts all over again. So yeah, the charger 4 was a successful part of the performance upgrade. What exactly happened to the others, I will tell you in another video. But you saw that the system is already up and running, and it's just in testing at the moment. I'm still waiting for a few components which have to be fixed. Yeah, I know that especially this topic about removing excess energy in some countries is very important. I always have questions about something like this, or following other YouTube channels, like for example in Germany, they always have something like this in mind. And yeah, it is now really like that our excess energy during the day is reduced very much. Systems like this, which can follow the actual amount of energy, this can of course have a big impact of what is still going out or remains inside on your property. I hope you found this interesting. So please comment on the down and like the video, subscribe to the channel, and I see you next time.